Okay, guys, I'm recording. Okay. Okay, so I want to talk to you about something for a second. Look at this title, exponential. What goes along with exponentials? Does anybody know? Exponents, and what goes right with that? Do you remember? It's actually logs. So, who says, yeah, I don't really like logs so much? Raise your hand. Okay, that is not an uncommon opinion, okay? All you people who raise your hands, I used to be a hater too. I used to hate them, but I'm not anymore. You know why? Because it's really pretty easy. You just have to remember all the rules and apply the rules to the equation. That's it, okay? So I think today you're going to feel really good about the first half of the lesson and pretty good about the second half. But I think maybe better than pretty good. We'll see, because I'm going to do a better job than I did last period. Okay, exponential function. Okay, take your pencil, and I want you to draw an arrow to that x, and I want you to write variable in the exponent. So if it has a variable in the exponent, it's exponential. Okay? Okay, see this box right here? Right up above it, I want you to write the word parent. Okay, so a parent graph would look like this. So take your pencil and I want you to dash in an asymptote right there. The asymptote needs to be there. Everybody in the room, make sure everybody is with me and participating, because this is going to go better if we are. Everybody in the room, tell me what axis the red line crosses. Does it cross X or Y? Crosses Y, so everybody go Y equals. Where does it cross the Y axis? At 0. Yeah, so the asymptote is Y equals 0. Okay, you guys, graphing an exponential is so easy, literally, and it's not a race. I'm just trying to tell you how easy it is. I think you are going to get to the point where you can graph an exponential in like 30 to 45 seconds, like so fast. Here's why it's just so easy, guys. Look, see this point right here, this y-intercept, it's 0, 1. It's always going to be there if the graph is a parent graph, okay? The other point that's always going to be there is 1, b, okay? All you have to do is plot those 2 points, connect them, make sure you have your asymptote, and you're done, okay? You guys, look at this graph right here. I didn't give you the exact equation for this graph, but you could totally come up with it, because look, you have 0, 1, and then back to the origin, we went right 1 and up 2. So my base must be 2. So the equation for this graph is y equals 2 to the x, because the 2 is the base. So I went right 1, up the base, it's got to be 2. Okay, who says I understand that? Let's see. Okay, great. Okay, come back over here. Let's find the domain. Okay, is domain X or is domain Y? Everybody tell me. It's X. Everybody right now, put your arm the way the x-axis runs. Put your arm that way. Okay, this is X. Now go perpendicular. Do I start at the left or do I start at the right? Start at the left. And I travel to the right. Is there any X that would not touch that graph? There's not. So what's the domain? All real numbers. So make an 11 and then turn it into an R. Okay. Range is X, everybody, or Y? Y. Put your arm the way the y-axis goes. Now go perpendicular. Start up or start down? Start down. Now imagine pulling this guy up, right? And what values are going to hit it? Everybody tell me, what's the range? It's the whole bottom half is missing, right? So it's 0 and above. But does it include the 0?
No.
It does not include the 0. So the 0 is going to be close with a what, everybody? A parenthesis. Good. The y-intercept, if it's a parent graph, is always going to be 0, 1. And on these problems, you guys, b is greater than 1. So it's a growth factor because the base is bigger than 1. Okay. What was I going to do? I was going to do something right here. I don't remember. Okay. Huh? I was going to say something. It was going to be so good, but I forgot. I'm sure I'll remember and say it in a second. Okay. See those 3 graphs that are there? That is a typo. And I'm so sorry, but they're not supposed to be there. The same is true for these other graphs. There's this wonderful graph sitting there. I think what I did this summer is I just cut and pasted, and for some reason I kept the graph on there. So I apologize. So it's going to be a little messy, and just kind of is what it is. Oh, I know what I was going to do. See, I told you I'd remember. Okay, you don't have to write any of this down. Y equals 4 to the x power is a parent graph. The reason it's a parent graph is because there's no right, left, up, down reflection. There's no adjustments to it. This right here is not a parent, okay? Because the +1 shifts it up 1. You don't need to know that yet, but just know that it's not a parent. That is not a parent because of the negative. This is not a parent because of the +3. So if it's a parent, you have just a base, and the exponent is x, and that is a parent graph. Who says I understand what a parent is and what a parent is not? Okay, great. So everybody look at this guy. Y equals 2 to the x. Is that a parent or not a parent? It is a parent. So watch how easy you can graph this. See the table of values? The table of values is silly. Like, you don't need the table. All you need are those 2 points, okay? First of all, guys, since it's a parent, I know I'm going to have an asymptote right there. I know for sure I'm going to hit the point 0, 1. So everybody go up to 0, 1, make a dot, and then go back to the origin. My base is a 2. So from that origin, if I go right 1, I go up 2. So this is the only graph where that is correct. That's really the graph. Okay, now everybody look at that right there and just shout this out. What is the domain of that graph? Tell me. All real numbers. See how nice it is if everybody just responds. We can just cruise right through. The growth factor is the base. What's our base? A 2. That's it. And the asymptote is not 0. It is what, everybody? Y equals 0. Good. Now, in my opinion, we're done. Because the table is if you don't know how to graph it so easily like we do, right? So it's kind of, we're doing this in a backwards order, and we're kind of just jumping through hoops. So we're going to fill in the table. Just know that I think the table is silly and unnecessary because the table is supposed to help you graph it, but we've already graphed it, and now we're going back to the table, okay? So what if x was a 0? 2 to the 0 is a 1. If x is a 1, 2 to the first is a 2. X is a 2. 2 to the second is a 4. You guys, what is 2 to the negative first power? 1/2, yeah, because the 2 comes down. What about 2 to the negative second power? What's that? 1/4. I'm going to make this connection. I'm only going to do it one time. Everybody look. -2 1/4, left 2 up a 4th. That's a point on my graph. Left 1 up a 1/2, it's a point on my graph. 0, 1 is there. Right 1 up 2. Right 2 up 4. They're all just points on the graph. But I know how to graph it faster than that. So anyway, that's it. Okay, let's do this one. You have to pretend like that exponential graph is not there. It's just supposed to be a blank XY axis. I'm sorry. Okay, I know it's a parent graph. The second I know it's a parent graph, I'm going to graph in the asymptote. Because if I don't do that, I'm going to forget to draw the asymptote, and then I'm going to lose points, okay? So the 0, 1 is always on there. Then my base is 2.3. So I'm going to go to the origin, and then I'm going to go right 1 up. Everybody shout out, how far up do I go? 2.3. See how easy? So it's right there. So the graph is almost right. It's just a little steeper, okay? So draw it in, and then maybe just go like this. Just a little like scribble, scribble, scribble. Okay, sorry about that. Everybody in the room, tell me the domain. All real numbers. This is easy. What's the growth factor? 2.3. The asymptote is not 0. It is y equals. Be very careful. Good. Now let's go in a backward order and let's fill in the table. So 2.3 to the 0 is a 1. 2.3 to the first is 2.3. 2.3 to the negative first, I'm just going to write that as 1 over 2.3. And 2.3 to the negative second, I'm going to write that as 1 over 2.3 squared. And I know that's a little messy, but I don't care because I think the table's silly. Okay? I'm not going to ask you for a table, and I don't think they're going to ask you for a table. Okay. The next one. Is it a parent graph? Everybody tell me yes or no.
Yes.
Okay, watch how fast. It's not a race. I'm just trying to show you how easy. Look, draw your asymptote, plot the point 0, 1, back to the origin, right 1, up, talk to me. Up 3, draw it in. There it is. Done. Do a little squiggle through that thing because that's not supposed to be there. Okay, domain, shout it out. All real numbers. Growth factor, 3. Asymptote, y equals 0. This is so easy. Who says this is so easy? This is leading you to logs. And logs are just as easy. So you're going to be fine. Let's fill in the table. Sorry. 3 to the 0 is a 1. 3 to the first is a 3. 3 to the negative first is 1/3. Easy. Okay, now look at this one. This one's going the other way. Okay, why is it going the other way, guys? Because b is less than 0. B is less than 1, sorry. You don't have to memorize it though, guys. I don't need you to do this. I don't need you to, there we go. I don't need you to say, oh yeah, b is less than 1, so it's going to swing the other way. You don't have to do it because it happens automatically, okay? Everybody write down the point 0, 1 and 1, b. And you'll naturally go, oh yeah, it's going to swing the other way. And I'll show you how that happens in a second. Everybody look at that graph. Shout it out. Tell me the domain. It's all real numbers. It's been the all real numbers the whole time. What's the range? Greater than 0. So you could say y is greater than 0. You could also say from 0 to infinity, zeros with a parenthesis. Which one of those two is interval form? Because I think you forgot that on the quiz. Which one's interval? The parentheses one or the inequality symbol? It's the parenthesis business. That's inequality. I mean, that's interval. Yeah, interval. Sorry. The y-intercept, if it's a parent, is always going to be 0, 1. The asymptote is missing. Dash that guy in. It crosses the y-axis at 0. And there's a typo in the next line. This lesson, you guys, I don't know if I've told you this or not, but I have, I worked 60 hours this summer editing. And this has been the worst one by far in terms of how good this is. So anyway, it's fine though. Cross out growth and put decay. As it travels from left to right, it's decreasing, which means it's a decay factor, and the decay factor is B. Okay? All right, here we go with question 2. Again, ignore the graphs that are there. I apologize. Watch how easy, okay? Stick right here with me. Everybody in the room tell me, is that a parent graph?
Yes.
It is a parent. So look what I know. I know I have an asymptote right there, so fill that in. I know it hits the point 0, 1. It's always going to hit 0, 1. Now stick right here with me and listen closely, okay? The next point is 1, b. So I'm going to put the pencil at the origin, write 1, and then up, tell me. 1/2. Okay, now everybody look at that. This is what's going to go on in your head. You're going to go, well, it's lower. That's weird. And then you're going to go, oh yeah, that just means that the right is lower and the left goes up. Okay, now freeze right here and let me show you something. If I can connect this right now, it's going to be so good. Just watch if you want to. 1/2 to the negative first. What if I'm over there on the left, right? Left 1. Well, look what that is. That's a 1 to the negative first and a 2 to the negative first. So the 2 comes up and becomes a positive. The 1 comes down and becomes a positive. So if I'm left 1, how high up do I go? I go 2. So to figure out the other side, all you do is take that 1/2, you guys, that you have right there, and you just flip it upside down. So that would give you a 2. So you're just going to say, okay, I know I'm up 2 right there. I'm going to curve it in. There's my graph. That's it. Take your pencil and just do a little, don't do a crazy scribble because you don't want it to be all messy. And that looks really so bad, and I'm so sorry. Maybe when you get home, you could white it out. I don't know. So your graph looks really good. Okay, domain. Everybody look at that graph and tell me what the domain is, what it is. What is it? All real numbers again. Range is, talk to me. y is greater than 0. I think most of us probably want to say 0 to infinity. Is a growth factor or is it a decay factor? It's a decay. And what's the value? 1/2. The asymptote is, just shout it out, everybody. Y equals 0. Where's it going to cross the x-axis? It's not, so we're going to say none. The y-intercept is 0, 1. For what x values is the function increasing? Now, everybody listen to this. Increasing, decreasing, constant. You start at the left. So I'm on the left of that graph, and I travel to the right. Watch my hands. I'm traveling along the graph. What's my graph doing the entire time? Decreasing. It's going down, right? So where is it increasing? I'm going to say none. And then I'm going to add in the word decreasing. And you can't say all real numbers for decreasing. Remember, there are the x values from where it begins to where it ends. So that would be negative infinity to infinity. And that's it. Okay, now the table is silly. It's okay, let's fill it in. 1/2 to the 0 is a 1, 1/2 to the first is 1/2, done. Okay, let's do the next one. 30 seconds, we can graph it. Everybody, is it a parent graph?
Yes.
Yes, it is. Dash in the asymptote, hit the point 0, 1, go right 1, up 2/3, that's about 0.6. And then you go, oh yeah, it's going to swing that way. On the other side, I'm going to go left 1, and then I'm going to go up. How far, everybody? You flip it upside down, right? So it's 3/2. What is 3 over 2 as a decimal? 1.5. Yeah. So you're going to go up 1.5. It's going to curve in. It's going to look like that. There you go. You know, I don't know what the best way to get rid of that stupid stuff is, and I'm sorry that it's there. Okay? Domain is, shout it out, guys. All reals, ranges, 0 to infinity. Is it a growth factor or decay? To decay, so circle it. And what's your rate? 2/3, right? Asymptote is y equals 0. X-intercept is none. Y-intercept is 0, 1. Where's it increasing? None, never. Where's it decreasing? Tell me. Negative infinity to infinity. Because it's a decay rate. It's going smaller. Who says this is easy? Easy, easy. See, told you. Okay, next one. You know, I know this is crazy, but it might be easier. Oh, let's do the table. 2/3 to the 0 is a 1. 2/3 to the first is 2/3. I know this is crazy, but it might be easier if you write it as a fraction. 3/4 to the x. 3/4 is 0.75. Parent, yes or no? Everybody in the room?
Yes.
Yes. Don't forget your asymptote. So start with your asymptote. 0, 1. Write 1 up. Tell me, guys. 3/4. Then you go, oh yeah, this guy's going to swing down. So this guy's going to be up. So he's going to be 4/3. What's 4/3 as a decimal? 1.3 repeating. Yep. So it's going to swing like that. Goes like that. Done. Okay. Take your pencil, scribble that out. I'm very sorry. Okay. Domain. Shout it. All real numbers. Range. 0 to infinity. It's always the same. Is it a growth factor or decay? Decay. What's my factor? You could say 0.75 or 3/4. Who cares? Asymptote. Y equals 0. X-intercept is none. Y-intercept is 0, 1. Where is it increasing? It never is. Where is it decreasing? That would be negative infinity to infinity. Let's fill in our table just in case you get one. 3/4 to the 0 is 1. 3/4 to the first is 3/4. And you could put 0.75. It's fine. Okay. Now that is the easy part of the lesson. This next part, it's fine. I feel like I didn't do the greatest job teaching it last period, but I'm going to do a great job this time. So it's going to be better. Who says I'm totally good so far? I feel really good. Okay, great. Okay, is this linear or is this exponential? Okay, watch closely. From 0 to 1 goes up 1. From 1 to 2 goes up 1. From 2 to 3 goes up 1. From 3 to 4 goes up 1. Okay, now From 7 to 11 goes up 4. From 11 to 15 goes up 4. Right here is up 4. Right here is up 4. Is it linear or exponential? It's linear. Okay. Now, who says, I want to say something a little more, but I'm afraid I'm going to confuse you. Who says, I totally understand that's linear. Like, that's easy and clear. Okay. I'm going to add on one little thing. Just add that right here. What if this said 6? Then this would be a +2. That doesn't mean that it's not linear. But if this jumps 2, this would have to jump what? 8. Yes. Yay that you knew that. That would have to be a 31. It's still linear because 8 over 2 is the same ratio as 4 over 1. So we're still linear. We're good. If it's linear, determine the slope. Okay. I'm going to show you the easy way, and then I'm going to show you another way. Okay. So slope is y over x. So the change in y is 4 over the change in x is a 1. So your slope is just a 4. That's all you have to do. If you struggled with that, everybody write down the point 0, 7 and 1, 11, and let's find the slope. So it would be m equals 11 minus 7 over 1 minus 0. That's 4 over 1, which is a 4. So you get the same slope either way. And I just randomly chose 0, 7, and 111. You could choose 0, 7, and 423. Who cares? Because the slope is consistent. Who says I'm with you? Okay, great. Write an equation that shows the relationship between the variables. Okay, so everybody go y equals, I know the slope is a 4, so it's 4x. Now I have to have the y-intercept at the end. Can anybody in the room can you see the y-intercept right now? What is it?
7.
It's a 7 because the y-intercept is found when x is a 0, so it's just right there. That's all you have to do. Who says I'm done? I'm good. I'm good. Let's see who's good. I'm done. This is over. Okay, let's do number 4. Up 1, up 1, up 1, up 1. Let's do the bottom. Up 2, up 4, up 8, up 16. Is it linear? No. So now we know it's exponential. Okay? Now, I don't want you to think about it as what you're adding. The second you realize that it's exponential, I want you to figure out, what am I multiplying? So you switch because the adding wasn't consistent. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. Okay? So if it's exponential, determine if it has a growth factor or a decay factor. Guys, is ours a growth or is ours a decay?
Growth.
It's a growth because the y's are getting bigger, right? So it's a growth factor. What is the factor? It's a 2. Okay? Now, write an equation that shows the relationship between these variables. Okay, so it's going to be y equals. Your base is going to be a 2. I'm going to put it in parentheses, and it's always going to be raised to the x power. Sometimes you have to have a number in the front. Sometimes you don't have to have a number in the front. Okay? You guys, let's go backwards. So if x was a 0, can anybody tell me what y would be using the same pattern? Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So what would I have to multiply by 1 to get a 2? A 1. So whatever is this, the 0, 1, whatever goes with the 0 goes here. Okay? So that's my equation. Now, of course, we know that's awkward, and the 1 is really not necessary to write because it doesn't do anything. So that's your answer. Please listen. If I were doing this problem on a test or a quiz, I would totally check my equation. So look, if x is a 1, is 2 to the first 2? Yes. Is 2 to the second 4? Is 2 to the third 8? Is 2 to the fourth 16? Is 2 to the 5 32? Totally works. Works for every single one of those. Who says, I'm good? I understand that. Okay, great. Okay, let's do this one. I have a feeling this is going to go so much better, especially this one. Okay, look right here. What do I add to 0 to get 1? 1. What do I add to 2 to 1 to get 2? 1. Let's check if it's linear. What do I add to 4 to get 4.4? That would be 0.4. What do I add to 4.4 to get 4.84? That's 0.44. Is this linear, everybody? No. The second those don't match, you know it's exponential. Okay? Now, they want you to finish the table. I'm going to kind of do this in a little bit of a different way. Okay? So I actually kind of want to go to D, which is the equation. So I'm going to go y equals some number and then some base raised to the x power. You can never have plus or minus anything out there. It's just those two numbers that we're trying to figure out. Okay? Now watch how simple this is. 0, 4, that 4 right there is the y value initially. Where does that go? Remember we talked about it? Is it the first blank or the second blank? Look right, let's go back. It's okay, no problem. Look right here. Remember how we said that was 0, 1? And the 1 goes where? Everybody tell me. First blank. So let's come back over here. So tell me what to put here. A 4. Okay, now, the only other thing I have to do is I have to figure out what I'm multiplying by to get that, right? Well, look how easy it is to figure it out. See the second y value, 4.4? You just divide it by the previous one. So you just go 4.4 divided by 4, and you get 1.1. So if you took 4, you don't have to do this, but punch in 4.84, guys, divided by 4.4, what do you get? 1.1. So I know I'm multiplying by 1.1 every time. Who says I understand that? Okay, the 1.1 is your growth factor. So that goes there. There's your equation. Of course, you don't need all those underlining things, right? But that's your equation. Now, you can get the next ones 2 different ways, okay? I'm going to show you both ways, actually, okay? Grab your calculator. Everybody have your calculator in your hand. And punch in 4.84 times 1.1. When you do that, you get 5.324. Who says I see that? I see that. Okay, now grab your calculator. Now stick right with me. We're going to put a 3 in for x into that equation and make sure I get 5.34. Okay, 5.324. Everybody go 3 store enter. Then go 4 parenthesis 1.1, close it, raise it to the mem bar, enter, enter, and I get 5.324. So you can get it either way. Let's find the next one using the table. Watch how simple. I don't think we've done this together, this little piece, so watch. Everybody go 4 store enter. Now I want you to hit the up arrow, this up arrow right here, guys, and then hit it again. And now do you see you're back on top of that equation, right? Hit enter again, and that gives you the next value. So it recomputes it with this time x being 4. So it's 5.8564. So I did that. I completed the table. If it's exponential, part C, if it's exponential, does it have a growth factor or a decay factor? Guys, is it growth or decay? It's a growth factor. And what is it? 1.1. I know it's a growth factor because of 2 things. My numbers are getting bigger. What's the other way I know it's a growth factor? Guys, tell me. It's greater than 1. You're exactly right. If the value of x is 10, what would the value of y be? Well, that's easy. Everybody go 10, store, enter, and then go up, up, enter, and we're going to round this to 3 digits, and it's 10.375. That's it. Who says I totally get this? I get it, I get it. Okay, great. Example 6. The value of a car is a function in the age it is in years. The value of the vehicle models this equation. The vehicle will be owned for only 5 years. Answer the following questions. Okay, the first thing I want you to do, guys, is I want you to go x equals y equals. So x stands for the number of years. The Y stands for the value. You guys, I would love it if you could answer this question. Is the value of this car going up or down? It's going down. How do you know it's going down? How do you know that? 0.92 is less than 1. Don't say it's going down because the value of all vehicles goes down. That's false. What if you have a collector, right? And you never drive it? That value is going up. So it could, in rare instances, cars can go up. Okay, can anybody tell me the purchase price of the vehicle just by looking at the equation? What is it? Yeah, remember that's where you start. So we're just going to go $25,000. What is the growth factor? Okay, this is important. So everybody write down the word factor. Okay, and then I want you to put exactly, make sure you're writing this down. What is there? So do you see the 0.92? That is your growth factor. 0.92, done. Do I have a growth, growth factor or decay factor? This is going to be decay, right? Because it's getting smaller. We already talked about that. What is the growth factor or the decay? The growth rate. Cross that out and put rate. Or the decay rate. Okay, now this is important. To find this, okay, write down the word rate. And then go, if it's a decay, bless you, then you go 1 minus the decay factor. If it's a growth, you take the growth factor and subtract 1. So for example, mine is a decay. So I'm going to go 1 minus 0.92 is 0.08. That's the answer. That's the decay rate. Now let me explain this and then you'll understand and maybe it'll help you remember. 0.08 as a percentage is 8%. So listen to this. If I take 0.92 and that's what's left, which is 92%, how much did I lose? 8%. So every year I'm going to lose another 8%. Who says I understand that? That's why that's that decay rate. Okay. What will the value of the car be in 3 years? Everybody go V of 3 is equal to 25,000 times 0.92 times 3. Let's store it in because I have a feeling we're going to have to keep doing this. So everybody go 3, store, enter. Then go 25,000, parenthesis, 0.92, close it, raise it to the mem bar, enter, enter. We're talking about money. So please don't say 19,467.2. Let's round it to nearest cent. And where does the dollar symbols go, guy? At the beginning or at the end? At the beginning. Put your dollar sign in and you're done. Practical domain. Domain is how many years? What's the smallest number of years I can own this car? 0. Could I actually own it 0? Yes. I go to sign the loan and whatever, right? There's an accident and something slams on the car and the car's demolished. I'm not going to ever own it. What's the longest I can own the car? 5. It was up in the directions. 5. Practical range. Range is the value. Do I start with 25,000? I what with 25,000? I end. Why do I end and not start if 25,000 is the beginning number? Somebody answer that question. 25,000 is the biggest. You got to go smallest to biggest. How do I find the smallest value? Somebody tell me that. How do I find the smallest value? This has been on quizzes and tests for sure before that you've seen. What's the longest I can own it? 5 years. So I'm going to put in a 5. Everybody go 5 store, enter, up, enter. And if I own it for 5 years, it's going to be 16,477.04. There's my practical range. Okay, now we're going to graph it. Okay, come over here and let's go 1, 2, 3, 4, and 5. And let's label that years. Over on the left side, I have to go 25,000. So if I go like this, guys, look. If that's 10,000, and that's 20,000, and that's 30,000, so I'm going up 4, I think that would be good. Is this going to be a line? Is this going to be a straight line? Somebody tell me that. Everybody talk to me. Is this a line?
No.
No, it's exponential decay. Guys, look. My graph is supposed to look like that, right? Because it's getting smaller. I could plot 2 points. Look. 0, 25,000 is right there. I know that 5 is 16,000. That's going to be about right here. And I could literally just curve it in. Now, see, it's hard to make it like curvy because that's a pretty good one. You get the idea. I might have gone too low too fast, but you get the idea. It is not linear. Who says I understand? Okay. Question 7. We're going to do question 7 in groups, okay? I'm going to start you, though. I'm going to start you off, and you're going to finish it. Okay, here we go. You have a job that starts at $30,000 a year. You're offered 2 options. Plan A, every year you get $2,000. $2,000 extra, $2,000 extra, $2,000 extra. That plan B is a certain percentage. Everybody go like this. Highlight that percentage right there. And I want you to draw an arrow and say that that's going to definitely be what? Do you know? It's exponential. It's going to be exponential. This first guy, is he going to be linear or exponential? He's linear. Okay, draw a line. Plan A, plan B. X stands for the number of years. Y stands for the salary. Okay? I want you to try to come up with an equation. If anybody gets this right, I will be floored. I will be so excited. Okay? You're going to pair up with a person. Okay? So look right here. 2, 2, 2. Okay? You guys, it's going to be kind of hard. It's hard when people are gone. Let's go 1, 2, 3, 1, 2, 3. Okay? You guys are 1, 2, 3, 1, 2. Go. I want an equation for A and B. Everybody go. Okay? Everyone should be talking.
Plan A is pretty easy. It's just per year. X is years, so it's 2,000 X plus 30. But I think the plan B is very true.
33.5
and then X this where oh that's percent then
because isn't it the one where it's like with the exponent x?
0.0.
So like that?
To the power of X and then you times it by.
Wait, what's the number? What's the number that goes for?
Yeah, I know.
Something like 30. Right? Or would it be 0 because I don't even, yeah, 1 year. If you work 0 years,
Maybe you
you're making
move it.
0. You can't make 30. You would make
Is it really just 3.5?
working 0 years. Working 1 year is 30,000.
Hold on. No, it's, you
But I think
subtract the
it's
71
I thought it'd be like
minus
this.
0.025. No.
That is a 3.5.
Would it be
No, that
one
would-
because if you're multiplying
Crap, stay away from it. We need more time.
Wait, is it
I don't think
3.5?
it is.
Or is it 0?
I think it's 0. It's 0.
Ready?
No, we need more time.
0.
Oh, it's time.
Dang it.
You're just sitting there.
Look at us go.
Okay. Last period. I randomly called on a group, and this is what they said. Look, y equals x plus 2,000. So then this is what I said. So if 1 year passes, then their salary is 1 plus 2,000, which is 2,001. So they start at 30,000 a year and then they go down to $2,001 a year. Is that right?
No.
That is not right. Okay, so someone tell me the right equation. Thanks, bud.
Y equals 30,000 plus 2,000x.
You're exactly right. So 30,000 to begin with, plus every year that passes, another 2,000. Who says we knew that? My group knew that. Okay, great. Now, if anybody gets B, I'm going to be so happy. Okay, I will be like, you're a rock star. You're all rock stars, but I'll be especially happy. Okay, so y equals, guys, exponential. Look, you have to have a number here. You have to have a number there. It's raised to the x. Okay, I think everybody got the front number, right? What's that? 30,000. Okay, so it's that base that's the tough one, right? 3.5 as a decimal is 0.035. Okay, so if that was right, then I would go 30,000, parenthesis, 0.035, close it off, raise it to the first. That means the second year you would make $1,050.
That's the worst deal ever.
That's the worst deal ever. That's the worst job you can imagine, right? So what? How do I need to change it and why?
You have the 1 because then that'll be the 3,000.
Yes, and you said that so well. Look, you have to have the 1 because the 0.035 is the raise part, but the 1 pulls the 3,000 back into the picture. Who says I understand that? Okay, so I want you to put right here that if it's a growth, if it's increasing, you have to go, girls, you have to go 1 plus and then put the rate. So 1 plus 0.035. Okay? Yes.
Hey, why do you do 0.035? Why can't you just do 3.5?
Because you can't use a percentage in an equation. You have to turn it into a
I
decimal.
didn't see that.
Yeah.
Okay.
You okay?
Makes sense, yeah.
Okay, so that's it. Okay, question 8.
Wait, so when it's decaying, you do rate minus?
Yes, and I think we actually have one. Oh no, this is an increase. I'm so glad you said that. I'm so glad you said that, and I should probably include that. So everybody just put a little note right here, okay? So what if it was decreasing, let's say by 4%? Okay, let's just say that. So then your equation would be y equals, the 30,000 always goes here. Now, if it's decreasing, I know that number is supposed to be less than 1, right? Because it's going down. What would the number be? Can you tell me?
0.96.
0.96. Yep. Because 1, remember I said you take the 1 and subtract the 0.04. That's where you get the 0.96. Good. That was awesome. That was a great connection to say that. Okay, question 8. I was going to say, why don't you do it by yourself? Let's just do it together, right? So we can get going on corrections. Okay, you want to purchase a car that costs $32,000, but you can't afford it. Every year you wait, the car is going to increase by 4.5%, okay? is this linear or is this exponential? Immediately you know exponential. So don't even look at linear. Okay. So does it have, so write an equation that represents how much it's going to cost in 2 years. Okay, so everybody go, cost equals. Here's a number, it's raised to the x. I want to change this. I'm going to change it because I think we need, let's make it decreases. Because the last one increased, so let's make this guy decrease. So then we get an example of both, okay? So everybody tell me the first number I write down. 32,000. This is decreasing. So I know that number is going to be less than 1, right? So how do I figure out the number? What do I do? 1 minus, don't say 1 minus 4.5 though, 1 minus 0.045. And that gives you 0.955. Am I right? Okay, there's your equation. Does it have a growth factor or a decay factor? Everybody tell me. It's a decay, and what is it? 0.955. Okay, now, if you say, add another question. What is the decay rate? So the factor is the number that's there, right? The rate, do you remember it was about 15 minutes ago?
1 minus.
It's 1 minus 0.955, and that's where that 4.5% comes in. So that's the percentage that it's decreasing, which is the decimal is 0.045. Okay, so just know the difference between those. How much will it be worth in, or how much will it cost in 5 years? So it's 32,000, and it's 0.955 raised to the 5th power. Now this doesn't make sense, because is the cost of a new car going to decrease over time? No. So it's not going to make sense. I changed it to decrease. I wanted an example of both. It's fine. We're just going to go with it. So I'm just putting it in my calculator, and I know this is money, so it's $25,419.49. Dollar sign in the front, always go to the nearest penny. Okay, now let's graph it. It's going to start at 32,000 and it's going to go down. Okay, so we're going to go 1, 2, yeah, let's go by ones, it's okay. 1, 2, 3, 4, 5. And it's going to be 32,000, and then it's going to go down from there. So I'm going to do the same thing I did before. I'm going to do every 4 marks is 10,000. So it's 10,000, 20,000, 30,000. I know I'm off my grid for 32, but I'm just a tiny bit off my grid, so I'm not too worried. Okay, so initially it's 32,000, so it's going to be just a little bit above that. After 5 years, I'm down to like 25, so it's down like about that. And then this is not linear, so give it a nice little curve like that. And we could actually just keep extending it like that. Okay? That's it. I feel like that was okay. Who says, I think I understand. I felt like it was okay. Okay, I did so much better. Sorry, period 3. Do you have a question, sweetheart?
Yeah, I'm kind of confused on.
Okay, hold for 2 seconds. Okay, go ahead, honey.
Decay rate and the decay rate.
Okay, I'm glad you said that. Okay, everybody sketch this on your paper somewhere, okay? Shh. Y equals 4 times 1.06 to the x. And then do another example. Y equals 4 to the 0.82 to the x power. Okay, and I want you to write factor and rate. And then over here, I want you to write factor, and I want you to write rate. Okay, look at the first example. Is it a growth on the first one, or is it a decay? It's a growth. So I want you to put growth, and I'm putting it in red because it's really kind of part of the answer. You need to know that it's growth. Why is it growth? Because 1.06 is bigger, okay? Watch how simple, sweetie. So the factor, you literally write exactly what's there, 1.06. To get the rate, you take that growth rate and you subtract 1. So you would go 1.06, subtract 1, and that gives you 0.06. That tells you that every year that passes, it's going up 6%. Do you understand that, honey?
Yeah.
When
Okay.
you try to add one and to subtract one, I don't understand.
Would I add one? No, because yes, watch over here.
Well, that's.
I think it's always a subtract. It's just if it's 1 minus the number or the number minus 1. Let me finish this and see if it helps, okay? Look at the next one. Growth or decay? Everybody tell me. Decay. So fill in the word decay. Okay. Factor, put exactly what's there. 0.82. Decay rate. You go 1 minus that 0.82, you get 0.18. So the decay rate is 0.18, which is the same thing as 18%. 0.06, same thing as 6%.
So
It's always a minus. It just depends the order. The first one is -1. Let me say one more thing, and I think it will help as well. Everybody just sit and listen. Think about buying clothes, okay? If you're like, oh yeah, I can do that. That's easy, right? That's easy. Okay, look at 1.06. If you go into the store and that's $100 item and you're paying 1.06 of the price tag, are you getting a good deal? No, you're paying over the price tag. So it's a growth, it's higher. How much more am I paying that I'm supposed to? 0.06. Which is 6%. Who says, I understand what you just said. So I'm paying 6% more than I was supposed to. Look at the other one. That's a sale. I see a $100 item. How much am I going to pay for in that scenario? 0.82 of the 100, which is 82. So how much am I saving, right? That's 0.18. I'm saving 18%, where over here I'm getting ripped off 6%. Who says I understand that now? Yeah, I thought that would click. Yeah.
So for like 1.06 and 0.82 in the like problem, the word problem, would it be 82%?
You could write it as 82%.
Or like
Or
when they give it to
18%.
us, it would be that number though.
I,
You have to do something before, like subtract 1.
so are you, is it this right here that you're still kind of wondering about?
Well, no, because like just on 7.
Okay, let's go back to 7.
How we did the growth 1 plus the rate.
Oh, when you came up with the equation. So that is when you determine the equation. Do you understand? So if you're coming up with, on these other ones right here, the equation was already there. This is when you're figuring it out. So if this is a growth, you do the 0.035, but you have to include the 1 with it. So this thing right here, sweetie, is different than what we just talked about, because that's when I'm coming up with the equation. This is when I already have the equation and now I'm trying to answer some questions. So make those two things separate in your head. You good? Anybody else? Okay, awesome. Okay, so now we're going to do corrections, okay? I feel like that was better than last period.